Hello. You'll have to excuse the bad sound, and also my kids are watching a movie in the back. Um, but I wanted to make this quick kind of emergency video because it appears that Desmos has changed um, the way that the way that it shows probabilities. It actually makes it easier, but I could understand how it could maybe be confusing for you. So, what I wanted to do was just go over these problems from 2.6 and 2.7. Um, I wanted to go over them just to kind of show you how this would work in Desmos now that Desmos has been updated. And this update literally took place this week. I was just doing these problems on Thursday, and it was with the old version. And then sometime Friday or today, Saturday, they decided to change it for whatever reason. So okay, um, in so these example this example that we're looking at here comes from 2.6. This is the binomial distribution, and we did all these examples, in class or in the lecture if you watched it online. But I'm going to redo them just to show you how this would work in the new version. Okay, so number 4 says, according to Experian Automotive, 35% of all car-owning households have a red car. If we take a random sample of 20 households, compute the probability that exactly 5 households have a red car. So we would use the binomial distribution, and in the binomial distribution, we need to put the sample size, 20, and then the probability of success, right, 0.35 in this case. And then, the way that we did it in class is we would write down the min and the max, but that's not even a thing anymore, right? So let's take a look at what this looks like in Desmos now. So if you type in binomial dist 20, 0.35. So this looks a little different, and it says cumulative probability. If you click on that, and by the way, you can still click the magnifying glass to zoom in on it. But it has these different options, right? Where you can look at the probability x is between certain values, the probability x is less than certain values, the probability x is greater than a certain value, and this outer one we probably won't ever use. But this is the probability that x is either less than something or greater than something else. So to do the probability that x equals 5, I think what you would do, and I haven't done this yet, so this is me testing it out in real time, but I think you would use this inner thing where x is between different values, and you would probably just put 5 in both locations. Yep, that seems to work out. You can click this little down arrow to get more decimal places if you need, or you can just round to the 3 decimal places it gives you or whatever. So anyway, so that's 0.127. So what I would like for you to do when you're showing your work is just write down exactly what you typed into Desmos. So in our case, we typed probability x was between 5 and 5. And we got approximately 0.127. Okay, for part B, if we want to do between 8 and 10, well then we would just do 8 and 10, 0.346. So I'm not going to show you the work on that because hopefully it's pretty self-explanatory. That's what you would do there. For part C, for part C, we're asked for the probability that at least 2 households have a red car. Okay, so again, we're going to use the same binomial distribution, but we're looking for the probability of at least 2. So we want the probability x is at least, that's 2 or more, right? Greater than or equal to 2. And so that's exactly what we're going to want to type into Desmos. So looking at Desmos, Left isn't going to do it because we want this sign to be greater than or equal to. So I think if we do right, that's what we want. And we want x to be greater than or equal to 2. Okay, so 0.9979. Okay. Okay, for part D, again, we're going to use that same binomial distribution. This time we want the probability that they have more than 2 cars. X is greater than 2. And now here we're going to use the same facts that we took note of in the original lecture, right? If x has to be strictly greater than 2, then that means that x has to be greater than or equal to 3, right? The reason that that's important is because in Desmos, you're not going to have a way to put in a strictly greater than. It only gives you the greater than or equal to option. So we have to change that to a 3. 0.998 or 0.9979 or whatever. Okay. Hopefully this is making sense to you. Like I said, I think that in many ways the work is actually easier. Oh, I wrote down the wrong answer. 0.9989. Anyway, you get the point. And like I said, I think that in many ways this makes things easier. 9879. Holy schmoly. I keep getting this wrong. 987. You know what, you guys? It's Saturday night. What can I say, you know? 0.9879. All right. So then E and F, we want the probability at most 4, probability less than 4. So at most 4 would mean less than or equal to 4. Okay, because 4 is the maximum. Less than 4, right? Less than 4. If x has to be strictly less than 4, then that means x has to be less than or equal to 3, right? So this is the way that you would enter those things into Desmos. I think in order to get the less than sign to show up, you have to use the left. Okay. So that's how you would get those, and I'm not going to waste your time like showing you that over again. All right. So this is how you use the new version of Desmos for the binomial calculator. Now, we do need to talk about the normal calculator though. Okay. So let's take a look at the 2.7 stuff. So, so here, this is a normal distribution problem. If we want the probability that x is exactly 35 inches, then here we're going to use the normal distribution. And we have to put in mu and sigma. I think the mean was 38.72 inches, and the standard deviation was 3.17 inches. Okay, and here we would look for the probability x equals 35. Now let's take a look at this in Desmos. I'm curious to see what this looks like. So let me hide that one and do a normal dist with a mean of 38.72 and a standard deviation of 3.17. And let me zoom in on it. Okay, and now yeah, it looks like I get the same options. I don't know what area and bounds are. Oh, I see. Okay, well, you don't have to worry about the bounds thing. We'll just look at the area. So if I want the probability x is exactly equal to 35, then I should put 35 here and 35 here. And the area is 0. Just like we thought, right? So the probability is 0, just like we thought it would be. So, okay. So again, to show probability, x equals 35, well, we really entered that in as the probability that x was between 35 and 35. But that just equals 0. Okay. So for part B, probability x is between 34.9 and 35.1. Okay, we get that answer. No big deal there. For parts C and D, Okay, we want the probability that x is at least 35. Okay, so we're going to use the same normal distribution, but we want the probability x is at least 35. That means 35 or more, right? Greater than or equal to 35. Whereas in part D, we want the probability x is strictly greater than 35. But now, here's the tricky thing. So remember, for a discrete distribution, like the binomial, you have to jump up, okay? But for a continuous distribution, like the normal, this probability is exactly the same thing as this probability. The reason being that the probability that x equals 35 is 0. So it does not contribute anything to this probability, or rather, it doesn't contribute anything to it doesn't contribute anything to this probability. So these two things are the same. For a continuous distribution, they're the same. Okay, and so let's figure out what that would be in Desmos. So for that, I think we're going to have to look at the right, okay? And we want the probability x is greater than 35, so I'm going to change that to 35. Oops, 35. Okay, and there you go, right? We get that probability. And that would be the same answer for part C and for part D, okay? It's going to be the same. In a similar way, for part E and F, part E, we want the probability that x is at most 37. So that would mean x is less than or equal to 37. On part F, we want the probability x is strictly less than 37. But we would do this the same way, okay? The same way in both cases. My kids are starting to fight. Anyway, this time we would look at the left. We would put in 37. And this is going to be the correct answer for both part E and part F for the normal distribution. Okay. If that was all confusing to you, it's probably because you didn't watch the lectures, or that it was confusing to you to begin with. But this chart should help you. This chart should be very, very helpful for you. And like I said, I think these changes in Desmos actually make our lives easier. Like, I think it's easier to do this way. So for a discrete distribution, the probability that x is greater than 4 is equal to the probability x is greater than or equal to 5. But for a normal distribution, the probability x is greater than 4 is the same thing as the probability that x is greater than or equal to 4. And we have similar statements for less than or equal to. So anyway, that's that. Just a quick kind of emergency video. Hopefully it's not too much of a headache for you in the homework. Have a great rest of your weekend, and we'll check in with you again on Monday.